So next we have this resultant of forces. So as mentioned earlier, that resultant is the collective effect of all the forces acting on a body, or it is replaced by a single force. So the single force that can replace the system of forces acting on a body and produce the same effect, that is called as resultant of forces. So here we see that a block is exerted by a force 30 Newton to the left and 70 Newton to the right, and the collective effect of these two forces, that is summation of forces in the x direction, that is 70 towards right side minus the force which is acting on the opposite direction, that is 70 minus 30, it is equal to 40 newtons. So this block instead can be represented by a single force of 40 newtons, okay, and that too on the right side. So let me just rewrite it over here, and here it says that it is summation of forces in x direction, that is 70 minus 30, which is equal to 40 newton, and this 40 newton is going to push the body or pull the body towards right side. Okay, and even if I place the 40 Newton force instead of over here, if I replace it on the left side, it is going to exert a push. So here the force of transmissibility, the principle of transmissibility of force can be applied as well here. Next, if the several forces acting simultaneously at a point in a body, then the body is said to be in equilibrium. So you can observe here the 45 kilonewton is acting in the northeast direction and 45 kilonewton is acting in the southwest direction. So the resultant along this direction is neutralized, 0 it would be, and 115 kilonewton is towards west and 115 is to the east. So once again it is neutralized, and 70 Newton is towards the northwest. This is northwest and this would be southeast. So once again the effect is neutralized, and same way 20 is towards the north side and 20 is towards the south side. So that is how the summation of all the forces acting on this point O becomes 0, and the resultant force if the body is in equilibrium. Equilibrium, by this I mean precisely static equilibrium. So when it is a static equilibrium, the body is assumed to be in rest, and the resultant force acting on a body has to be definitely 0. Okay. So resultant would be equal to 0. Now let's take a simple case. If the system of forces acting on a body is said to be in equilibrium, if the resultant force is 0, so there is a 50 Newton force that's been applied on the right side and the same amount of force is applied on the left hand side, the net forces acting in x direction would be equal to 0, and this was what indicates the body is at rest.